Okay, guys, I'm going to do some examples using law of cosines here. And we can solve law of cosines when we're given, so the first option would be 3 sides of our triangle. And I'm just going to write out the basic, like one of our options for law of cosines. So I always think it starts off kind of like Pythagorean theorem. And then whatever these two variables are, we repeat them. So minus 2bc, and then we need our cosine. And then I think of it like kind of a big sandwich. So if A started, we'll use angle A. So law of cosines, like I was saying before, can be used when we have 3 sides of our triangle or 2 sides and an included angle. And we'll see that in our next example. But here we have 3 sides. To avoid our ambiguous case, because we'll have to use law of sines after, or it's an option, I always solve for the largest angle because there can only be one obtuse angle. So if we have an obtuse angle, this is going to be it. So I'm going to set this up solving for angle R. So for this one, instead of using A, B, and C, it'll be R, Q, and S. And then we'll be finding angle R. So I'm going to put in all of those values we have. I repeat these sides on here, and I'm going to be looking for cosine of R. So I usually put this pretty much all into my calculator at once. I would subtract 19 and 21.8 squared, and then, right, those guys would be gone. Then I would divide by the negative 2 times 19 times 21.8. So if you do it all at once, make sure your denominator is in parentheses. I need to do the inverse cosine of all that. And double check, but I got angle R was equal to 72.743 degrees. So it's not an obtuse triangle, but that will be the biggest angle in our triangle since it's across from the biggest side. So now you guys will notice that when I go to solve this triangle, I could do law of cosines again. That would be totally fine. Or now that I have an angle and its opposite side, I can set up law of sines. So I would use that angle again. And the side across. And we can solve for whichever other angle we like. I'll just choose Q. And solve here. Now this is the setup for the ambiguous case, but this is not an ambiguous triangle. We have 3 sides already given. So we don't have options. There's not 2 triangles. There's only one going on. So if you do get an ambiguous case here, you can kind of just ignore it because we shouldn't have 2 triangles. But we always, like I said, we always want to make sure we're solving for the biggest angle first. That way I know I don't need another obtuse angle. So when I solved over here for angle Q, you guys can solve it on your own. I got 48.305. And then subtracting those from 180, I got angle S to be 58.952. So that is our side case. A little more straightforward, you guys can always pause if you need to check that out, is our case when we're given 2 sides and an angle. So I'm not going to draw a triangle here, kind of get away from that to save some time. But we're given angle C, and we don't have side C. So we're going to be looking for side C. I always like to kind of see it out first. And I'm going to throw in everything that I have. So 8 squared, 5 squared, minus 2 times 8 times 5 cosine of 65 degrees. And this is great. I can throw it into my calculator. Don't forget to take a square root of all of it. So I get side C is 7.429. So again, you can always draw a picture if you want, but now that I have an angle and its opposite side, we can then set up law of sines. So I can say sine 65 over C equals, we're looking for another angle, sine A over 8. When I solved for angle A, I got 77.412 degrees. And then subtracting from angles C and A, we can get angle B and get 37.588. Now, if you're ever unsure about either using law of sines, right, or something like that, you can always do law of cosines again. So if I didn't want to solve law of sines to get angle A, or if we wanted to check for some reason, I can always use law of cosines, because now I've got A, I've got side C, side B, and we can always solve this to get angle A. So another option if you're not sure, but we should not get the ambiguous case. There's no ambiguous case for law of cosines, since here we're given an angle, angle C, and then the two sides around it. So when you're given side, angle, side, there is only one triangle that can be formed.